What we're going to do today is actually solve a polynomial by factoring. Okay, and so we've done all the factoring, and we've looked at the factors and doing all that. Today we're actually going to solve it. Okay, and I'll kind of show you some different examples, and then we'll do some graphing. So if you have your graphing calculator, you might want to get it out because we're going to use it today a little bit as well. The first ones that we're going to look at is we're going to look at equations that are already factored. So we don't have to do the factoring ourselves. So if I look at one that is GCF, and the biggest difference today is we're going to see an equal sign on our equation, okay, or make it an equation. All this chapter so far, we've just been given a polynomial, we've factored that polynomial in some shape or form, and then we just left it there. Well, today we're going to take it a step further where we're going to actually solve it and try to figure out what values of x make this equal 0. And because this is already factored, then all I'm going to do is take the two factors and set them both equal to 0. And the GCF part here is already equal to 0. So there's nothing to solve for. So that's one of my solutions. X plus 4 equals 0. We're just going to subtract 4. And we get x equals negative 4. And what we're going to say is that those are the two values that make this equation equal 0. And it's really pretty easy if it's already in factored form, right? There's not much there to do. We just set it equal to 0 and we solve it. Same would be true if we had one like this. This might be one that we've done by like slide and divide or something like that, okay? But we didn't necessarily have to do the slide and divide because it's already factored, okay? And we wouldn't want to FOIL this back. I could FOIL it and get the actual polynomial that we started with, but there's no purpose in doing that because today we're solving it. We're trying to figure out what values of b make this equal 0. And so we're going to set each individual factor.
Juniors, if you have not reported to the auditorium, please do so at this time. Juniors, if you have not reported to the auditorium, please do so at this time. Thank you.
So we set 3b minus 2 equal to 0. So we add 2, divide by 3. So that's 2/3. For the second one, we subtract 5, divide by 2, and that would be negative 5 over 2. Those would be our two equations, or two solutions, I should say. Okay, one more that's already factored. This one's a little bit different, just because it has another this one has 3 factors, right? Anything that has an x in it is considered a factor that I can set equal to 0. So x plus 5, and 2x minus 3, all 3 of those are my factors here. And we've seen some like this throughout the week where maybe we take a GCF of x out and then we could factor it by doing product and sum or slide and divide or whatever we're trying to do. And so we've seen some where we've had 3 factors like this. And now when we solve it, we're going to set all 3 equal to 0. So the only difference here is that we would have 3 solutions rather than 2 solutions. This one's already solved, so that one's done. This one we subtract 5. This one we would add 3 and divide by 2. And those would be the 3 solutions. Okay, so pretty easy if it's already factored, right? Well, what we're going to do today is we're also going to continue to factor. We're going to do some of the factoring that we've done throughout the week because it's going to give me some type of polynomial. And this one obviously is not factored because we see d squared minus 4d, which is its basic old polynomial. And our goal is going to be try to factor it, if we can factor it. And then find out what the solutions are going to be. Okay, so as I look at these two terms, first of all, we always want to make sure it's set equal to 0. If it's not set equal to 0, then we got to get it set equal to 0. This one is already set equal to 0. So as I look at the left-hand side, what can I do to factor that? Well, that's where we go through like all the different methods. But the first method we always look at is what? Greatest common factor. So do we have a GCF here? Yeah, we can take out a D, right? And so I'm going to take out a D, and that leaves me D minus 4. It's now fully factored, and then I just take both of those, set it equal to 0. D equals 0 is already solved. This one we add 4, and we get D equals 4. So that one's not too bad, just GCF, okay? All of the factoring that we've done this week could be in play. So we're talking GCF, obviously, but we're talking DOPS, we're talking product sum, slide and divide, grouping. Any of the factoring methods that we've done throughout the week, we could use today. So the first thing here, make sure it's set equal to 0. We look at the polynomial that we have. Is there a GCF? Is there something we could take out? No. Okay. So then, as we have two terms, okay, then there's really only one method that we're going to do when we have two terms. What can I do with x squared minus 9? Okay. Two sets of parentheses. Okay. Okay. We need one plus and one minus. Yeah. X times x is x squared. One's a positive 3. One's a negative 3. Okay, what method did we call that? You guys remember?
I think Eli knows.
I think Caleb.
Eli?
He's been whispering over here.
Isn't
Would-
it Dobbs?
It's DOPS. Yeah, it's DOPS. Be confident.
No, Caleb.
Then we set both of those equal to 0, and we get x equals negative 3, x equals positive 3. This one is one that we did earlier. X squared minus 9. Put x squared minus 9 into your calculator. And I know this isn't a perfect graph, but x squared minus 9, if you put it into the calculator, it's crossing the x-axis at negative 3 and positive 3, right? The y-intercept all the way here is going to be down here at negative 9. But we're really just looking for where does it cross the x-axis. Those are my solutions, right? So I want you to understand how those two kind of go together and how the equation and the solutions work together. So that would be one that is what we call a quadratic equation. A quadratic equation is anything with an exponent of 2. 2 places where it crosses the x-axis is the most it can cross. It's not always guaranteed to cross at 2. You might remember from parabolas that sometimes I could have a parabola come down and hit and then come back up, and it maybe only touches the x-axis in one place. Or If I have a parabola that looks like this, it never crosses the x-axis. We're not going to see that today, okay? Because this one does not have any real zeros, so guess what kind of zeros this one has?
Oh, imagine.
Imaginary, yep. So this would have imaginary zeros, and so the good news is we don't have to worry about that today. So that's good. Okay, one that looks like this. Do we have a GCF? Nothing we can take out, right? It's 3 terms, okay? So on 3 terms, first thing we talked about yesterday is, are the first and last perfect squares? 2 is not a perfect square. So perfect square trinomial is definitely out, okay? Can I do product and sum here? In order to do product and sum, what do I have to have? Slide and divide would be bigger than 1, right? Product and sum would be nothing here, okay? So product and sum, we're going to do it if there's nothing in front, but because there is something in front here, then this would be the slide and divide. Okay, so it's still going to be 2 parentheses. My product is going to be -4, and my sum would be 3. So I got to find 2 numbers that multiply to get -4 and add to get 3. Okay, what kind of signs do we want? Positive 4, -1. Okay, so we're going to go x plus 4, but because we're doing slide and divide, we're going to write a division sign here. And what number are we going to put on bottom of those 2? 2, whatever that leading coefficient is. So we're going to put 2 underneath both of those. If it reduces, we can reduce it. 4 over 2 becomes 2. So that's the easy one. Okay, 1/2 does not reduce, so we're going to slide the 2 over in front. And those would be our 2 factors. Okay, and that's where we stopped, right? Throughout this week, when we factored, that's where we stopped. We just found the 2 sets of parentheses. Today, we're taking it that next step further because we're trying to solve for x. And so now I'm going to set both of those equal to 0. And I get x equals -2. And then here, x equals 1/2. Okay. Now, here's what I'll tell you guys, is that just so you understand what we're doing and how you could check this, these are the 2 answers, the 2 solutions that make this equation equal 0. And so if I really wanted to check this, I could take -2, I could plug it in for x, and I could see if it equals 0. Okay? And so let's just do one of them. I probably won't do both, but -2. -2 squared would be 4. 4 times 2 is 8. 3 times -2 is -6. So 8 minus 6 is 2. 2 minus 2 is 0. It works. Okay? I could also take the 1/2 and plug it in, and it should also work as well. Okay? Both of those should make it equal 0. And you could even just put that into your calculator if you're not 100% sure, does it work or not, okay? Do these answers make sense? You can always plug it back into that equation, okay? So just so you understand what we're trying to find and what we're looking for, those are the values, those are the solutions that make that equation equal 0. Okay, 6y squared equals 3y. If it is not set equal to 0, that's got to be our first step today. all the ones that we've done up to this point were already set equal to 0, so we didn't have anything that we needed to do. This one is not set equal to 0, so that's got to be our first step, okay? We're going to subtract 3y. Now that it's set equal to 0, now we can do our factoring. First thing we should always ask is, do we have a GCF? Do we have something that we could take out? Okay, what are we going to take out of those two? 3y, yep. So 3y is my GCF, okay? We're going to divide both of those terms by 3y. So 6 divided by 3 would be 2. 2y's, take 1 away, would just be a y. 3 divided by 3 would be 1, and then y's are going to disappear. That's as far as we can factor it, right? Sometimes we may be able to apply a couple of different factoring methods, but in this case, GCF is all we can do. Anything that has a y on it, we're going to set it equal to 0. And then y equals 1/2. So those would be our two solutions. Y equals 0 and y equals 1/2. Okay. Okay, this one's a little bit weird, a little bit different. Because it's not set equal to 0, and because we have parentheses. So this looks like two factors, and it kind of is, except if it was set equal to 0, I could just take both of those and set it equal to 0, but it's not. It's got a 14 over here, okay? So the first thing that we're going to have to do is we're going to have to move that 14 over to the other side to set it equal to 0. So we're going to subtract 14. And the way it is right now, I can't factor, I can't do anything with this. So what are we going to have to do? We're going to have to distribute. We're going to have to distribute the a throughout the parenthesis, and we're going to have a squared minus 5a minus 14 equals 0. Hey, how are we going to factor this? What method? Is there a GCF? Nope, no GCF. Okay, we got 3 terms. Is 14 a perfect square?
No.
Nope. Okay, if I take the square root of 14, I don't get a nice whole number, right? So it's not a perfect square. We check that first because that would typically be the easiest one to check, okay? Next up would be product and sum. Can I do product and sum here? Is there something that multiplies to get negative 14 that adds to get negative 5? Okay, 7 and 2, and then we got to make sure we know what signs go where. Negative 7, positive 2. It has to add up to be negative 5 and multiply to get negative 14. Okay, and then to finish it out, once we have our two factors, we set both of those equal to 0. And that would be our answer. Okay, something I'm going to talk about real quick because the next problem that we're going to do is going to deal with this. We're going to write the equation given the zeros, Okay, so if I give you the two solutions, or what we also call the zeros of that function, then these would be what we call the factors of that function, and this is the equation that's equal to 0. Okay, so you got zeros, factors, and then your polynomial or your equation. So we're going to go backwards. I'm going to give you the two solutions. We're going to write the factors, and then we're going to find out what the polynomial is. Okay, so notice the difference here. If this is 7, what's the factor? It's a minus 7, right? Because it's the opposite. If the 0 or the solution is -2, then my factor is a plus 2. So these two are opposite because I got to set it equal to 0 to solve it. So if I were to give you one, let's a couple of zeros and ask you to write an equation that has solutions, and sometimes we call those the zeros, of -3 and +2. The first thing that we're going to do is we're going to write out the factors of those zeros. So the factors would be x plus 3 and x minus 2. But we want to put the equation into standard form. This would be what we call factored form of the polynomial. We want to put it into the form that we're used to seeing it in, which is what we call standard form. And so what are we going to have to do here? Just FOIL it. Yep, just FOIL it out. So x squared minus 2x plus 3x minus 6, which become x squared plus x minus 6 equals 0. Okay. Now, here's where we're going to use our calculators. And I'm going to use this one to start with just to show you what the relationship is here. Okay. Here's where your calculator can come in really helpful. If I were to put this into my calculator, let's graph this equation right here. X squared plus x minus 6. Let's put that into our calculator. Everybody have one?
I do second alpha and then. Oh, I don't even have the right thing. Second alpha.
The last one I'm going to talk about here, just to kind of tie everything together. We talked about this from the very beginning. This is what we call the factored form of the polynomial. Okay? If I ask you to solve this, what would be the 3 zeros of that polynomial? X equals 0, x equals 1, and x equals 2. Okay? Let's put this into your calculator just like that. Y equals x, parenthesis x minus 1, parenthesis x minus 2. Okay, so there's my 3 solutions. Do we get a graph that kind of looks like this? Okay. Crosses the x-axis at 0, 1, and 2. Obviously, the shape looks a little bit different. It's not a parabola now. This is a cubic function, and it kind of makes like a snake-like graph because it has to cross the x-axis in those 3 places. Okay. And so that one's just a little bit different graph. Okay, so you'll have a few problems today where you're looking at graphing it and putting it into your calculator and looking at the solutions and how they relate to that graph. All right, that's all we got for today.
Everyone keeps telling me. No, you don't know if it is though.